Thanks, Embra. Thanks, everyone. Have you ever faced a production incident due to RDS scaling issues? Or even better, have you ever struggled implementing DynamoDB into your workloads? I'm Lorenzo Hidalgo, staff software engineer at Serverless Guru, Master in Science in IT Management, and AWS Serverless Community Builder. During the past years, I've been reviewing, fixing, and architecting AWS services with heavy DynamoDB usage. During this talk, we'll do a quick introduction and overview of the differences between SQL and NoSQL, the relevant design choices that we need to take when implementing DynamoDB, and a few tips and tricks to avoid the most common mistakes I've been seeing. For those in the crowd, I hope no one here that is not aware of what DynamoDB is, here we have a word cloud with the most used words used to describe this service. As we can see, NoSQL, serverless, managed, and performant. In short terms, DynamoDB is a NoSQL database that's completely managed by AWS. But what is NoSQL? What's the difference between SQL and NoSQL? In order to better understand that, let's do a quick exercise. Let's say you have to explain to one of your parents or even grandparents what a relational database is. What's the first thing that comes to mind? Most of you have probably thought of tables, where we have, or even compared to Excel. Here we can see we have rows, columns, and a fixed schema, where the user can see everything of the data, and sorting or filtering on any column should be feasible without any significant performance impact. But what about NoSQL databases? How should we imagine those? The easiest way to understand and think of NoSQL databases is like this. An archive full of drawers and folders, where each folder and drawer has a specific name tag, and each folder could contain anything inside. For example, one folder could contain the curriculum of a candidate we want to hire, and another folder could contain images or the test results of a student. Knowing that, if someone asked you to pick all folders with images inside of them, with having only access to the name tags, which are the person's names, it would probably be a time-consuming task, since you would need to open each folder, analyze the contents, and then separate the ones that actually have images inside. That difference is already hinting to the fact that NoSQL databases are not really intended to be queried by anything other than the actual access pattern. There are a ton of other differences between SQL and NoSQL, but as this is being recorded, you can check the table later. I just wanted to remind everyone of one of the main differences, and that difference is probably one of the most forgotten ones. We were talking before about transactions. Data consistency, it's one of the biggest differences and the one that is probably most forgotten ones. SQL databases or relational databases have asset consistency for both data and the operations you might want to use. For example, using transactions. DynamoDB or NoSQL databases don't have that type of consistency. They only provide eventual consistency in order to improve availability and performance. This difference is really important, since this might be a deal breaker depending on the workload. For example, banking transactions, where in order for that service to work correctly, we might need that asset consistency. Now that we have covered the differences, and almost everyone should already know what DynamoDB is, the important part would be to know how to get started. What are the steps that you should take, and what are the most important things that we can't forget about? As mentioned before, we should always think of NoSQL databases as archives with drawers and folders. Once we have this in mind, it is very important, as it affects the design decisions that we will take. The first step would be to gather requirements. We need to know what the business needs are. After that, we need to know what data we need in order to fulfill those requirements. How many data models do we have? How big are those data models? And more importantly, how are those data models related? Are all data models independently? Do they have one-to-one or any other type of relationships? This is crucial, as we need to first understand all of the above before we start thinking about access patterns. Knowing and understanding the access patterns are crucial, as the design on the primary key will be determinantal on how your application will perform in the long run. Going back to the folders and drawers example, we need to ensure that all our access patterns, or at least the most used ones, can be queried and filtered only by using the drawer name tag and the folder name tag, so the primary keys. This is important, as depending on how we configure or how do we design those primary keys, we'll be able to use one or another command to retrieve the data. And the relevant part of choosing the command or knowing what command we can use is that it will be the command, the one that will set the efficiency of our application and our requests. The easiest one should be get. As the name implies, we need to know the complete key material, so the complete primary key, and it will return a single item. Another one should be query and scan. Here we can already think, or the name already implies, that it will apply a given condition and return all the elements that match that condition. Query being intended to apply the condition on the key material. That way we know that we need at least part of the key material in order to use query. And scan is mainly intended for you to be reprimanded for its use. Or, jokes aside, what should be the last resort for retrieving data. The last one, and probably my favorite, because it flexes on how good you were able to design your tables and your access patterns, is batch get. Batch get item will allow you to retrieve up to 100 items if you're able to provide the complete primary keys for all of them. The tricky part here is that both DynamoDB and scan, as it's underlined there, it will scan up to 1 megabyte of data, meaning that an empty response from a query or a scan doesn't mean that there's no records in your database that match your condition. It only means that the 1 megabyte that was scanned by DynamoDB doesn't contain a record matching that. The thing that actually means that is that for the three last of them, we'll need to implement pagination. That way, we will ensure that DynamoDB has actually processed everything that we need. So, we now know the differences and what we need to access our data. Now that we know how we access the data and what we need to access the data, we should start thinking on how should we design the tables. The easiest one-to-one comparison between SQL and NoSQL would be having different tables. For example, if we were to design a blogging application where we need to store both authors and article data, we could have one table for each. Here at the top, we have a table for authors, and at the bottom, we have a table for storing articles. Each table having its own IDs. This showcases the first problem. Right now, you can get authors by author ID and articles by article ID. But there's currently no performant way for you to retrieve articles based on the author ID. It would be like the first example that we had, where DynamoDB would need to open each folder and check the insights to see if the author ID matches our request or not. An option to overcome this would be to add a secondary index, meaning that we could create a secondary index on the articles table, making it now searchable on the primary index, on the article ID, and on the secondary index on the author ID. This, at least in theory, looks like it resolves the issue, since The access pattern is now part of the folder name tag, so we can retrieve the items based on the article ID. But we still need to consider that joins are not supported on DynamoDB. That means that if our front-end application requires both author and articles to, for example, display the author profile, our backend API would need to send two different requests to DynamoDB. The first one to get the author data, and the second one to get the latest ID for that author. But having to do two different requests isn't the only drawback of using secondary indexes. Secondary indexes can be thought as creating a read replica, where DynamoDB under the hood will just replicate the data, ordering it to match the new access pattern. Secondary indexes also mean that you can't perform gets on the secondary index. You'll only be able to perform queries or scans. And even worse, it will increase the cost, both by having expensive write operations, since you will need to write to the primary and the secondary index, and storage, since you will need to store almost duplicated amount. But also due to the possibly inefficient access patterns. For example, by adding conditions on body. But there are still some scenarios where global secondary indexes can be a good fit. And for those ones, we should always have in mind or use attribute projections. Attribute projections is just the fancy term to define a set of attributes that we want to replicate or create a read replica with. The less attributes we choose, the lower the cost impact we'll have. Another option, instead of creating the secondary index, would be adding a sorting key. So here we can see we have the partition key as author ID and the partition key as article ID. This can only be done on new tables. Remember, we can't update the primary key on tables that already exist. That's why I emphasized the planning stage earlier so much. Implementing the partition key as author ID and sort key as article ID would allow us now to search and retrieve articles by author ID. But we would still need or still be forced to send two different requests to DynamoDB in order to get both author and article information. The best part of using a partition and sorting key is not only the fact that you can now search by two different attributes or sort the data by two different attributes, but the fact that it will allow us now to use overloaded sorting keys. By using overloaded sorting keys, we'll be able to use single table design. The idea of having overloaded sorting keys is having sort keys where you will add different attributes to it to make it easier to search. As we can see here, we have on the top the author information, so the author model, and on the bottom the article information. Going back to the previous example, we can see now then when our front-end application retrieves the author profile, so the author information and the latest article, we can retrieve everything with a single request. In brief, a single table design is storing different data models in the same table, thanks to overloaded sorting keys that allow us to easily differentiate the models based on its key format, optimize our filtering and sorting operations by the request numbers. Sorry. And the best part of it, reduce the cost by reducing the number of requests we need to send, and thanks to avoiding overfetching. Less read capacity units we use, the less we will pay for it. A good example for it would be if we were to have a really big data model, such as, for example, the student information, where one application will need the student profile, the student grades, and the student classes, but another part of the application will only need the student profile. By dividing the student data model into 3 different ones, we'll be able to avoid that overfetching. Having seen the different options and access pattern designs, what should I choose? Is it true that single table design is only good on paper, or only for pros such as Alex Debris? Both designs options, multiple and single designs, have its use cases. And in some cases, I've even implemented them both at the same time for the same project. We just need to consider the pros and cons of each option. For example, when we talk about flexibility, multiple table designs is a clear winner here. No model dependencies between each table, meaning it's way more flexible. For simplicity, the same. Simple requests, since you only need the ID for the multiple table or the table that you actually query. Single table designs usually have overloaded sorting keys and complex queries to retrieve the data. When it comes to management and performance, here we see a switch, where single table design is usually the most benefited one, since monitoring a single table requires less effort, and single table design usually perform better as they have more optimized access patterns. When it comes to cost, the same thing. Single table designs tend to be more cost efficient. We don't only need to focus on the strengths of the different design patterns, but also on the actual use cases and how those tables will be used. For example, when we work with independent data models, like static text or translations, or when we want to implement DynamoDB streams to capture changes and trigger other services by them. For those scenarios, usually working with multiple tables is the most cost-efficient way. Since independent data models, you don't need to have any similarity between the different tables, and with DynamoDB streams, you will only be triggered by the changes you actually care about. When we work with highly coupled data models, where most access patterns require a join-like experience, or where granular access, like the student example that we had before, the idea here would be to always tend to use single table design with overloaded sorting keys to make our workload more cost efficient. Now what? You might be asking yourself. We've gone through the design. Now it's time to think how we interact with DynamoDB and the different tables. I won't get too technical here. I'll just go through the most common mistakes and the tips and tricks to avoid them. The first one, I hope everyone here already knows about, but is how we add or update data on DynamoDB. SQL, it's very simple. We have insert into and update where. If we try to insert something where the ID already exists or update something that doesn't exist, it will just fail. DynamoDB is different here. We have put item and update item, but DynamoDB assumes that the developer knows what they are doing. Meaning that if you try to insert an item with an ID that already exists, it will just override it. Or, even worse, if you want to update something that doesn't exist, it will create a partial record only with those bad attributes that you wanted to update. The default upsert logic might be wanted in some cases, but in most scenarios, we don't really want it. For those, we can use condition expressions, which would be the equivalent to the where clause in SQL. By using condition expressions, we can avoid that upsert behavior. We can do independency checks, and even better, we can use conditional updates or business logics in our requests. For example, if we want to update a specific record, but only if it exists and it is in the correct state. Now, don't be shy. How many of you have implemented parallel or sequential requests to DynamoDB? You know batch operations exist, right? They allow us to send put or get operations in batches, meaning that we will be able to either retrieve multiple items from a single table or store multiple items into different tables. And the best part of it is the retrieval. With batch get, we'll be able to retrieve up to 16 megabytes of data instead of the 1 megabyte of data that would provide the query or the scan operation. Another good point would be pagination. As I mentioned before, you need to paginate in order to retrieve all the data. I know you know it exists. You should always push for it to be implemented. It's really easy. For query and scan, just look last evaluated keys. For batch get or batch write, just check the unprocessed items and send it as part of the next request. That way, we ensure that DynamoDB has processed the expected amount of data. Interacting with DynamoDB. The previous ones were fairly basic, and hopefully you're already familiar with them. But this one is a bit more tricky. Always, and I mean always, expect concurrency. Meaning that you can expect multiple services trying to update the same item at once. Just always prepare for it, since we don't have the transactions that they were explaining before. You should help or prepare for it by avoid storing all the information under a single attribute or using nested attributes. Instead of storing a full object as part of one attribute, store them granular way. That way, it will be easier to only update the data that you actually care about. You should always try to prevent updates on data that you don't really need, either by using conditional updates, conditional expressions, or the if not exist statement. And this one really triggers me every time I review something, is there are more actions than just set when you're trying to update something on DynamoDB. You should always leave atomic operations up to DynamoDB, either by using add, remove, or delete actions. So what should I remember? I know I've gone through a lot of information. The main things that you should remember today are the access patterns should always be queryable by the primary key. Multi-table design for independent data. Single table design for join-like experiences. And condition expressions to implement business logic as part of the request or avoid the upstart. Leave atomic operations to DynamoDB, add, remove, and delete. They also exist, not only set. And the last one, the most important one. When you work with DynamoDB, think before you implement. Otherwise, you'll end up having to redo your work in the long run. Now that we've gone through all the details, I'll ask you for only one thing. If you haven't tried DynamoDB, give it a try. If you already have DynamoDB as part of your workloads, review them again and see if they could be improved with anything that you heard today. I'd also like to point out that I'm organizing a hackathon, free, online, starting next week, with $9,000 as part of the prize. If you want to join, you can just scan the QR code and click on the button. There's also my contact details as part of that QR code, so feel free to reach out via LinkedIn or after this talk. Thanks, everyone.
Thank you so much, Lorenzo. So DynamoDB is like one of the three popular, like the most popular, the favorite services of mine. So also as you, so don't worry about it. So is there any one question that we can get before jumping into the next?
Lorenzo, thank you for the presentation. It was awesome. I would like to ask a technical questions. So let's say that you have a single table design and you are overloading the table. So in this example, we had the author row starts with author hashtag and then the author ID, and then we have articles which also have the similar PK. So now let's say that we would like to query the author by let's say age information, and that's why I think implementing a global secondary index would be wise for age column. But since you have a single table design, you also have the GSI field for the articles rows as well. So would you prefer using the same GSI one for the articles rows as well, or would you create GSI 2 column for the articles for the same purposes?
Tricky question. So going to the author's age, you can easily have that as part of the overloaded sorting key. You could have, for example, author, hashtag, and then the number that you want. That way, when you retrieve from DynamoDB all the authors, you'll also be able to sort them by the age. In terms of creating multiple GSIs or just one, it depends on the data that you will actually need. As I mentioned, attribute projections are a thing and we should use them. So if the access pattern that relies on one GSI only requires 2 fields and the other access pattern only relies on 1, then it's best to have different ones. Otherwise, if they rely on the exact same data, we can just update the GSI to have pre-K and SK, so primary, partition, and sort key, to allow for both access patterns.
Thank you again, Lorenzo. So thanks a lot for coming all the way. And like, I just want to say one thing about this hackathon. So it is like I'm a serverless, I'm very much into serverless, and these guys are doing a great job about like running this hackathon. Like I just wanted to take your attention once again about this because it's going to be a great one. Thank you again. And here is a gift.
Thanks a lot. Thanks, everyone.